Okay, thank you for watching this video. Let's study about potential and kinetic energy in electric field. And this contains two basically subject. One is how to deal with the energy state, and second one is you have to calculate the potential energy in the electric field. So this is twofold. But once you understand it, it's pretty simple. So hopefully you can understand you can have a pretty clear understanding. Uh, okay, so potential energy. So first, we wanna study what is the energy state. And actually, when we talk about energy, there are two kinds of energy. Always, one is potential energy, and the second one is kinetic energy. So you can always these two are only factors that create the energy. So you can write the energy of one state equals to potential energy plus kinetic energy. So this is one of the most important information that you have to understand in this video. If you understand this one, basically 50% of today's lecture is done. And so potential energy is dependent on the distance, basically distance in the electric field. And the potential energy is a little difficult to understand because it's not tangible, it's not seeable, but please just accept that fact that potential energy exists, especially in the electric field. And kinetic energy can be measured by weight and mass. So basically, the faster the kinetic energy is going to be larger, and the heavier weight and velocity. And if you have a the larger weight in an object, the more kinetic energy is going to be. And like I said, so this problem is all about the preservation of energy, which means that the energy of, let's say, spot 1 and spot 2 are always going to be equal. So this can write down energy spot 1 equals to energy spot 2. So these are the basics that you have to remember. And the next we want to move on to the equation that you have to remember. So the first equation you have to remember is how to calculate the kinetic energy. And the kinetic energy can be calculated out as a joule, energy. And the equation is half multiplied by mass, this m is mass, divided by v square. V is velocity. This is pretty simple equation. And the second one, how to calculate potential energy, this is more the simple equation, which is Q E D. Q is charge and E is electronic field and D is distance. The distance is a little difficult, the concept, but so let's say that you have a charged object, and always you wanna write this spot 1 as 0, and you wanna see how much this object is going to be moved, and the distance means basically here. So which means that if the object didn't change at all and stay at the same place, the potential energy is going to be 0 because D is going to be 0. And it's also important that you have to know the direction of the electric field. In that case, you always have to remember that electric field goes from plus to minus, and since this is from plus, this is going to be 0 to, if this distance is d, this is going to be negative d. So so this is something you have to remember. Yeah, it's kind of confusing, but I think the best course of action is the electronic field direction and the distance directions are always opposite. If you think this is plus, this distance is going to be negative d, not positive d. So this is something you wanna remember. And the again preservation of energy. I told that this equation is the most important equation, and this one too. And if you plug this PE plus KE into this one, you can also write PE spot 1 plus KE kinetic energy spot 1 equals to PE spot 2 plus KE spot 2. Yeah, when you solve a problem about this type of potential energy and kinetic energy, you always wanna start with this equation. So if you remember this one, basically 80% of the problem is done. So it's that simple. So let's use this knowledge to solve a problem set. Okay, so the problem is a proton is initially at rest, which means that the initial velocity is 0. And after some time, a uniform electronic field is turned on and the proton accelerate. So this is a proton problem. So proton has a charge. It's pretty small number. Usually, charge Q. Usually this is provided, so you don't have to remember it. And it is 1.6 times 10 to the negative 19th coulomb. And the mass of the proton, again proton is the smallest charged object, so the mass is also pretty small, but it exists. And it is this small, basically 1.67 multiplied by 10 to the 27th. And the magnitude of electronic field is 1.49 multiplied by 10 to the 3rd Newton per Coulomb. What is the speed of the proton after it has traveled 4 centimeters? So you can, it's always useful to write a cartoon so that you can understand what is going on. So you have a electronic field like this. This is positive side, this is negative side, and the electronic field always go from positive to negative, and this electronic field magnitude is 1.49 multiplied by 10 to the 3rd Newton per Coulomb, and you have a electronic, the proton, and the proton is traveling. And the original, so let's say that this is spot 1 and this is spot 2, and the original velocity is basically 0, so v equals 0, and we need to calculate the speed of proton after traveled 4 minutes. So this v, let's say this is vt, v2 is not known, and the distance from spot 1 to spot 2 is 4 centimeters. But again, you really have to remember that this is not plus 4 centimeters, but this is actually negative 4 centimeters. Remember that this one, the distance is always opposite to the direction of the electronic field when you want to apply this equation. So this is negative 4 centimeters, and which means 0.04 meter. So this is what you have, and basically what you have to start with is this KE1 plus PE1 equals to KE2 plus PE2, this equation. And KE1 is half of mass and B1 square, and PE1 is QED and equal 2 half of MV2 square plus QE D2 and D1. Now remember that this B1 is 0, and this spot one this is also D equals 0, and here is D equal negative 0.04 meter. So, and if you plug this B1 into here, this is going to be 0, and again if you plug this D equals 0 into here, this is also going to be 0. So basically you can write that 0 equals to half of MB2 square plus QED2. So equation got a little simpler, and now you want to plug all the value into here. M is this one, Q is this small number, E is this, D2 is this, and we don't know V2. Okay, let's just plug all the values into here. Then you're gonna get 1.67, 10 to the negative 27th multiplied by 1.6, now 10 to the negative 19th, and the electric field is 1.49, 10 to the negative 10 to the third, and the distance is, remember that this is negative number, so 0.04. And now this is positive number and this is negative number, so you want to move this term to the other side. This is V2, to the other side, so that you can obtain this B2. So in this case you can write as 1.2, 1.67 multiplied by 10 to the 27th V2 square equals to, since this negative is going to be cancelled out and turning into positive, it is going to be 1.6 multiplied by 10 to the negative 19th multiplied by 1.49 multiplied by 10 to the third multiplied by 0.04. Just we moved this term into the other side. And now what we wanna calculate is this V2, right? So let's make this equation simple. V2 square equal 1.6 multiplied by 10 to the negative 19th multiplied by 1.49 to the third and 0.04. Basically you wanna divide this, you wanna divide this number in both sides, and this is going to be half of 1.67 multiplied by 10 to the 27th. And basically you want to calculate this out. I know this is a little complicated equation, but after you use the calculator to to calculate this out, you are going to get 5.7 10 to the negative 9. And of course, this is the B2, and what your measure is B2, like not square. So B2 equal square root of 5.7 multiplied by 10 to the negative 9. And again, you want to use the calculator to calculate it out, and you will get the value of 5.6 10 to the 5th. And remember that we always use the standard unit such as meter or kilogram, so you can use the standard sorry, so this is okay, this is positive, also this is positive. And if you calculate this out, you can always use the standard unit. So the answer is meter per square. This is also unit. So this is the answer. Okay, so although this calculation was a little complicated, but the idea is pretty simple. You always start with this equation, and what you have to do is just plug into the equations and plug into the number so that you can get the unknown value. I hope you can understand how to solve the problem, and if you have any question, just comment anything in the comment section. Thank you. See you soon.